So you should now be able to see my screen, and I will start with the presentation. Today we have a couple of topics to go through. It will not be possible to go into every topic in detail, but I try to give you a good understanding of what is the driver, how we create them, what is necessary to add them to the system, and also some specialties like how can you add own libraries or how can you contribute them. The first topic is actually what is an instrument driver. The instrument driver in SweepMe you can find if you go, for example, to the sequencer and you have your modules. Then there are some modules that are called instrument modules, and these instrument modules, they can load instrument drivers. For example, an SMU module or a logger module. I have already added them to my sequencer, so we can go here to the SMU module. There's a tab. If I go to the SMU module, we have always there a field which is called driver, and there you can select the driver. These drivers are basically Python files. We can also open them to have a look into the code. It is basically a Python file with a class and different functions in there. To have a better look or to see all the drivers in the systems, we have the menu Tools, Version Manager, and there you can see all the content in the system. We can see these bold items. These are modules, and the instrument modules, like for example, LCR meter, login, or logger, they have additional items, and these additional items are the drivers. Let's go to a driver like the Logger Artifacts Engineering TZA 500. This is a transimpedance amplifier that was recently added. We can now see that we have here versions in the version manager, and here is the version of this driver. This is from 7th November of this year. We have an online version, and once we add this online version to the system, it's local. Yeah, this can just be done by download selected version or activate selected version, and it will be installed locally. Now the driver is on the computer, at least a version of it. And we can have a look into the driver by going also to this with a right-click action menu. You go to Open Version Folder. And this opens up here. And what we can see is we are now in this folder of this Logger Artifacts Engineering driver. And you can see there is a structure with here 3 files and 3 folders. The most important thing is this main.py file. This is what I just showed you here in this notebook, in this notepad. This is the Python file. There's all the commands in that make the communication with the instrument. Additionally, there's typically a license file in. We try to use MIT license because this is a very free license that gives all users a lot of freedom to do many things with it, to also use it commercially and so on. In the driver folder, you also find an info file. This is, we can have a look into it. This is just, let's open it. There just is a summarization or summary of different properties and also a hash that makes sure that we know that the driver was not changed if it was downloaded from the server, and different other IDs to make sure we can identify the driver in our software. Okay, and then there can be additional folders. These additional folders are, for example, the documentation. In the documentation, you can have a markdown file and also additional images. We have here examples. Examples are Python scripts that show how to use the driver in own Python environments. It means in your own Python projects. And we have libraries. And these are, for example, libraries that are not shipped with SweepMe. For example, here this FTD2XX library is needed to interface with the communication chip of the driver. This library is not shipped with SweepMe so far, and this means the driver needs to ship it with, comes with the driver so that the driver is plug and play. But as you can see, most important thing here is the main.py file. The rest is often, like these folders, are optional and can be added to the driver to make it more complete and more compact. Okay, so then let me have a look into my script. Yeah, the philosophy of the drivers is that they are plug and play. It means after download, you should be able to run them in a measurement without first installation of libraries and so on. Often, of course, it is needed to install additional hardware drivers for your instruments. This could be something like an interface driver for the COM port, a hardware driver in the Windows system. It could also be that you sometimes have to install Visa Runtime because SweepMe also uses uses Visa Runtime as a fundament to make the communication with especially scientific equipment. Okay, and how can you get such a driver into the system? It is basically possible to add any instrument where you can have code in Python to interface with the instrument. You can add any instrument to SweepMe. And there are different options how you get a new instrument into SweepMe. One thing is we offer this as a service to write these drivers. This is often used by many customers that we are asked for to implement it, because these commands for the drivers are open and also the API for the drivers is open. Everybody is, of course, free to also implement own drivers into the system. This is what we will also show today. And of course, what we also do often is we do it together. This means we write, for example, a skeleton of a driver, and you can continue to improve the driver. And this way, it is also a good opportunity to learn how to create drivers. As a last thing, how drivers are nowadays added to SweepMe is that the instrument manufacturers are asking for platform integration, and then the instrument manufacturers, let's say, pay us to get into the platform and make these drivers available for their products. This is also a nice development. Okay, now that we know what a driver is, it's the question, how can we start adding a new driver, or how can we also do modifications to a driver? The first thing that you can do, you can use a driver that is already available. For example, let's stay with this artifacts engineering driver, and we can make a right click on any version and use this action, create custom version. If we have created a custom version, we are free now, or you can see that we have locally now two different versions installed, custom and the version from our server. The server version cannot be modified. This shall ensure that you can have a well-defined setup at your computer. But of course, you can create these custom versions, and these custom versions can be opened in an editor. And now we have exactly the same code as in the server version, but now we are free to change, for example, here the options of the driver and add new commands to these functions in the device class and so on. So this is one way how people often make modifications to drivers to check new things, to add new options and new features. The next option is to create a driver from an existing driver. So here we have also this option, create new driver. If I create a new driver, I can make a completely new driver with a new name. This name is already given, but I can change TZA 500 and call it my version. And I create it. So now I have here for this instrument, let's take this out. And I have here a new version, and this is my own version. There is no version on the server. I can again modify this driver and make a customization. This is recommended when you want to make something very, very special, and when you add features that you cannot share or that you cannot share with the community because they are very specific to your setup. A next way how to create a driver is you can go to new, write new driver, and then you can add manufacturer, for example, my company and my model. I create a driver, and now I have a driver with logger, my company, my model. And if we look into the driver, open version in editor, we see there's already some code. And this code is coming from a template that has most features included that are typical for a driver. It comes with a couple of functions. And this, okay, I will go into the functions later on. But what you can see now is that we have here all the functions that you need, and now you can start filling them with the code for your instrument. So the next possibility to get a driver is to we go to File, Open Folder, and we go to the public driver, public folder of SweepMe. The public folder of SweepMe is a folder where we store a lot of additional specific data that is specific to your setup and to how you work with SweepMe. Independent from which operating system account you start your Windows, all people have access to this folder and can see, for example, the measurement data and so on. One folder is called the custom devices folder. And whenever we create a custom version, you can see here this TZ 500 my version. You can see this custom version that we created of the TZ A500 or this completely new driver. They will all land in this custom devices folder. Basically, it is also possible to take a folder, copy it, and rename it. This was automatically done by copy. And you can modify and start modifying the main.py. And after a restart of SweepMe, SweepMe will also find this folder and present it in the version manager. So these things that I showed you in the version manager, they are convenient things, but it is also possible to start from scratch, create a folder, create a main.py, add all the code, and you can run a driver and add it to the system. A last thing how you can add a driver is our repository, or how you can find drivers in the system. Let's go to the browser, and I already opened our instrument drivers repository. And what you can see is that all the drivers we develop, and for all the drivers that we are allowed to publish them, we push them into our GitHub repository called instrument-drivers. And here in the source folder, you can find all these drivers. So for the experienced users, it is also possible to add or to clone this repository to your local computer. Then you have all the drivers on your computer. And if I go one step back to where I can see here the documentation of this repository, there's also a guidance how you can add a Windows path variable like SweepMe drivers repo. And after adding this, the drivers will be found in SweepMe version manager. And you can find further versions and instrument drivers here in the version manager. This means once you are developing a lot of drivers, it makes sense to work with this repository or with your own repository, add the drivers there, and then you can simply add drivers also in your repo directory. Okay, now let's go really into the driver structure. I have now opened this driver logger, my company, my model. This was the driver that I created with creating a completely new driver using this new button, and where I now use the template of SweepMe, the template driver. This template driver can also be found as a normal driver, as a logger driver. Yeah, you can just download it. If you have a look into it, it will have exactly this code. And this is the template. So the structure of a driver, or the idea of our drivers, is that you have this class. This is a class that contains many functions. The class is inherited from empty device. This is a library that comes from our open source pysweepme library. It comes already with a couple of functions that every driver needs. So once we inherit from empty device, we know these functions are already part of our new device driver. The init function is a typical thing in Python that you initialize your class. And when we call super init, what you will find in every driver, it simply tells SweepMe or Python to also load and init the functions of our base class empty device. So once we did this, it means having this class function, this init function, and the super init function, we are actually already having a working construct working construction of a driver. Everything else is then something that you can add to modify the driver and make it also to add further features. An important part of these drivers is what you can say directly here at the beginning. You have different variables that you can define, and each driver has to tell SweepMe how many variables and units are there. Sorry, these two lines. For example, this driver has 4 variables, and the units are called unit 1, unit 2, unit 3, unit 4. If you don't have a unit, just keep it as an empty string. But this is how you tell SweepMe how many variables will be returned by the driver. And we can also define whether this variable can be plotted or whether it should be saved to the file. Further, there's also a short name, which is here called template. And this is what you see here in the value of the sequencer. This is a short name that quickly helps you to identify which driver was selected here or which instrument was selected. So coming back to the driver structure, we can now see there are a couple of functions. And the most important concept of a SweepMe driver are these semantic phase functions. Let's say this is something maybe what we invented at SweepMe, this phase function scheme, because this is something that helps us to create or to add a lot of instrument drivers from different types, whether it is a monochromator, a temperature sensor, or SMU. They will all follow this scheme of functions. And the idea was that we create functions that have a certain meaning, like, for example, connect. And the driver writer has to add code that makes sure the instrument is connected afterwards. But you don't need to use it. You can use it if you need to connect to your device, but if you don't need to connect, you don't have to use it. And then there are functions like connect, disconnect, initialize, deinitialize, configure, and so on. So what we made is we found for all the phases of a measurement, these semantic phases and functions that you have to do at some point. You have to configure your instrument at some point. You have to initialize. And this initialization, this configuration, and so on, this is independent whether you have a light source or electrical measurement or whether you have a vapor prober. You have to do something at this step. And by filling these functions at the correct position, you ensure that your instrument is correctly configured, initialized, and so on. And this also means that when we have multiple drivers, SweepMe can call these functions from each driver and make sure all instruments are initialized, all instruments are configured, and so on. And this is why all the instrument drivers in SweepMe immediately can be combined with each other without having tested this beforehand. And to get an overview over all these semantic functions that you are allowed to use in the code, you can go to our webpage or use the button F1 and you come to our wiki. In our wiki, you have here this sequencer procedure function calls. I already opened them. And here you can see a scheme of these functions, what they mean and when they are called. For example, some functions are only called once at the beginning when you start to press, when you press the run button. This means you have maybe 10, 15 drivers or modules in your sequencer. You speak to many different instruments, and at the beginning of a measurement, they are first all connected and then initialized. And this phase can then be used, for example, to make sure the instrument is there and it is responsible and it is connected. If this is not the case, you can throw an error in the driver. It means raise an exception, and the measurement will stop. So you can very early detect these instruments. You don't have to wait until they are used in the measurement and then raise an error. So you can really detect this very early. The next phase in our SweepMe drivers is when you come into a branch. So what does it mean? Let me open SweepMe again. You can see we have here one branch, but I could also have a second branch with another instrument, with different other instruments and so on. It is also possible that we can have sub-branches, right? So that you have first one branch, a second branch, and a third branch. And this means when we go to our scheme back, we have now functions that are called by SweepMe when your module enters an active branch. It means when your instrument gets really active and has to do something in a branch. Then there's a configure function. And this configure function is typically used to transfer the user input of the graphical user interface of the module to transfer to the instrument and set all these configurations. And it's very important to not do this initialize, because if you use the driver multiple times in multiple modules in your sequencer, you don't want to override at the beginning the configuration and the second instance of the second driver overrides it again. No, you want to just write it exactly at the moment when you want to use the driver and write the current configuration that has to be used. When you use the same driver in a second instance, in a second module, in a second branch, then another configure can make a completely different configuration. And this is also the way where then, after all instruments are configured in a branch, they are all powered on and switched on. Then there are some special functions that go already more deep into the concept of SweepMe, but you have also a function like sign-in, which means for every higher iteration in a SweepMe branch, you sign in is called and the driver can do something. This is sometimes needed, but it's already very special feature, but sometimes it is needed to know when there's a new higher iteration start and the instrument has maybe to reconfigure or to prepare again for a measurement. And now we come already to measuring a single point. You could imagine or maybe you think measuring a single point is quite easy. You apply a value and then you measure. But over time, we figured out there are many single steps inside a single measurement point. It means just to take a single voltage and current measurement of a source measuring unit, it already takes here more than 10 functions to go through all these processes that could come up during a measurement. We have a start phase and a finish phase. This is something you can prepare something and you can clean up something at the end. It is a little bit up to you what you want to do this, but sometimes it's necessary to have these phases to make sure for each point something is correctly set up and so on. Then there comes the apply phase. Now the set values that you create in SweepMe in the sequencer, they are handed over to the driver and are applied in the driver. Let's have a look at a driver, whether we can maybe also see this. I go here to an SMU driver. I open the driver. Now I scroll down and I see here my semantic phase function start. We have a connect. So we create an instance, for example. We have an initialize phase where we make for sure the firmware version is known, the hardware ID is known, we configure maybe the channel numbers, and so a lot of steps that has to be done once. Then comes the configure phase. And you see sometimes there's quite some code to send all the compliance values, to send different ranges and so on, and make sure the correct source mode is used and so on. Then we have here also some functions like power on and power off. And here you can see the apply function. And we hand over the new set value as self.value. You can transform it into your preferred data format like a float. And then, for example, here in this code, it is done like if the source mode is voltage, we use the voltage command to send it, like self.channel voltage is float of self.value. If it is a source mode like the current, so we want to apply a current, then we use self.channel.current here in this library for this instrument to set the new value. Okay, the value is set, but it does not mean that immediately the value is applied to the instrument. So this is why we inserted then the reach phase. And reaching is important for instruments that really take time to come to the set value. For a source measuring unit, setting the value is often enough to make sure it is applied to the device. But in reach, you can make sure that instruments like a temperature controller or a monochromator, that they reach their new position. You could also wait in the apply phase until they have reached the new set value. But this has a drawback. If you have multiple SMUs or multiple temperature controllers or multiple monochromators, they would do it one after another and you would lose time. Or imagine you have an XYZ stage with different linear stages and you want to move to a new XYZ position. Why should you do first X, then Y, and then Z? Better is to send XYZ as a new set value to the instrument. And then you use the reach phase of each driver to make sure they have reached there. Because in the time that you wait for the X-axis of a linear stage to reach the X point, the other two axes, y and z, can already reach their z value, and you don't spend much time. You only spend the time that you need for the longest operation of an instrument to reach its z value. Then there comes a phase that you cannot use in the driver, but this is simply an indication of that we now have a sleep time. Whenever you have a hold time in SweepMe and you say, please hold, then it will be applied now after reach. And this hold in SweepMe, like you have this hold module or this hold column in the sweep editor, this is now applied because now you want maybe to stress your device for a certain time, or you want to wait that your device or your system stabilizes. The next part is then this adapt. We have two functions that are called adapt and adapt ready. And why do we need them? Imagine you have a monochromator that goes to a new wavelength. And at this wavelength, you want to measure a photodetector with lock-in amplifier. The lock-in amplifier typically has a time constant, and it has to integrate over a certain number of time constants until fresh data is accumulated for the measurement. So if you go to a new wavelength, you don't want to measure immediately because you still have old data in the instrument, let's say, in the buffer of the instrument, and you really need to adapt to a new external situation. This can be a new temperature, or it can be a new wavelength. And then you can use these adapt functions to tell an instrument, please now wait 5 seconds, or please give me some return data until I know a condition is met. And adapt ready and adapt are basically two functions to start the process of adapting and waiting until it is finished with adapt ready. After that, you might want to prepare your instrument for a trigger. So a trigger ready means that you make your device, if you use a trigger, make it ready to wait for a trigger and be prepared for the next measurement. And now the block starts where you really do the measurement finally. For example, the function measure is the function that starts the acquisition of data and starts the measurement. This means this is sometimes maybe a bit confusing. We had beforehand a command that was called trigger that is now deprecated because the measure phase is the phase where you tell the instrument to start a measurement. And this means it is also the measurement where you have to maybe send a trigger if you want to trigger a measurement, because this is then also the time and the phase where all the instruments should get the information to start measuring. And again, here we have the concept that you do not wait and measure until the data comes back to the buffer and can be acquired in terms of reading them out from a buffer. You basically send the command to tell the instrument to measure, but you can use now other functions to request the result. It means you can send a function to the instrument, for example, to send the data back. It means some instruments immediately send data back, others have to be asked for to send the data now. And then you have also a function like read result, where you can read out the buffer. And the most important function maybe of a driver is then call. Call returns the data that was acquired during the measurement for a single point. Yeah, you have then these functions like process and finish, but in call you have to return the data. Let's have a look again into the driver. We see now here the apply phase. In this SMU, we don't have a reach, we don't have an adapt, because this instrument immediately goes to the set value and makes sure it is applied. But then we can start with measure here, a measurement process. It's maybe a bit complicated to see now through the code and understand it immediately, but it is here started. And in read result, we can retrieve the data, save it maybe to an object, and we save it, for example, to an object like self.v and self.i for voltage and current. And at some point, we have here this call function, and call returns now a list of voltage and current as we have defined it in the start of this driver. So this is one measurement point. And whenever SweepMe goes to new set values and you make sweeps, it will run through all these functions again and again and takes data for all the instruments whenever they have these functions applied or used. Call is, as I said, really important because you have to return as many values as you define by self.variables and self.unit. But the other functions you are free how to use them. You can also write a driver that just uses measure and call. And often this is satisfying your needs at the beginning because you can keep it simple and do testing. And these other functions are often then needed if you have, for example, multiple sensors. You have maybe five sensors from a certain company, and you want to read them out all at the same time. And then it makes sense to split these different phases and use these different phases to speed up your measurement. And then you might come to a situation where you want to use your driver with other equipment. And then it's also getting more and more important to use the correct functions here to make sure the procedure is correctly. But if you just write a single driver for logging one single sensor or using one instrument, these phases give you some concept how to go through the code and how to add it to the driver, but you are free how to use them basically. At the end, we have additional semantic phase functions, but that are simply making it symmetric. It means if you leave the sequencer branch, you want to unconfigure your instrument and maybe put it back into an idle state. You want to, of course, power off it. And at the end of a complete measurement, when everything is done, all modules have done their job, you want to deinitialize your instruments and you want to disconnect them to make them maybe available again for a new measurement. Sometimes you have to close a communication object so that you can open it in the next measurement and connect again. Okay, this is what you can find here in the wiki. And basically what people do when they write a driver, they add these semantic functions when they need them. Let's go back to our template driver. The template driver already has these functions included, like the initialize, configure. And the only thing it does, it makes some printout to the debug. This is maybe a thing that we could have a look at right now. Let's kick out all here these modules that I added just for visualization purposes. Let's take out drivers that we don't need. And now I'll use my logger 2 and use my company, my model driver. And let's start and let's activate it. Yeah, let's activate it and let's run a measurement. And what you can see now here in this measurement, we were running through a single point. It means we created in SweepMe sequencer just a single measurement because there is no repetition module. There's no module that creates a sweep or a variation. The logger module itself does only create one variation to create one measurement point. And now you can see that it creates debug commands like connect, initialize, configure, power on. And this helps you maybe to understand also and to see when these functions are called. Now we can simply change this driver. We go to initialize and make, instead of initialize, we write something, a change. We save the driver, and if I run the code again, we can now see that it kicks out here a change to the debug. So this is also a possibility to see how your code runs, in which phase you are, and now you can also start adding exceptions. Here's, for example, already an exception. Let's test this. The value was not valid. Please use something different. Here's as an example, then this exception is raised. I save the code, I run it, and a warning comes here. Driver has an exception. The value, this is the message. And then it says the debug widgets F2 for details. The debug widget is this debug widget that you can see here. You can find that via widgets, debug, show hide. And now you can see here the full error code. This is just a small error because we created it. But if you use, for example, a library, use it in your driver, and there is a complex error, you will find the complete Python code, error code in the debug. You can copy it and you can Google for the error, and you can use all the Python documentation to figure out why a library was raising an error. The next part of the driver that I want to speak about is the GUI interaction. What you can see here in this logger template is that we have a custom GUI, a GUI that is that was created by the driver. And how to do this? There are two functions that are called setGUI parameter and getGUI parameter, and they are used to define a GUI parameter dictionary and return this GUI parameter dictionary. And this tells SweepMe which user interface you want to have. SweepMe then looks into the dictionary and takes a takes a key of the dictionary. And this key is then used as the name of the variable, like here, string, check, combo. So these are just exemplary names for these types of user interaction fields. And depending on the value in this dictionary, it creates the user interface. For example, if you hand over a string, SweepMe creates a line edit for entering a string with the default value test. If you use a Boolean, it uses this true, creates a checkbox and makes it already checked. If you make it false, it will be unchecked as a default. You can also create a list, and the list will be defined or will be shown as a drop-down menu. You can add an empty line by defining a value with none, but you can also define a section by having a section name and defining it to none. So basically, this will be simply inserted as a text and will be made bold if it is a text. Otherwise, it is just an empty line. So this can help you to give a little bit structure. And we have here integers, floats, but it's also possible to have data types like a path. And a path then helps you that a user can click on it and can select a file. The file name is handed over to the driver, and then you can do whatever you want in Python with the file name, for example, load the calibration data, and so on. These GUI parameters are then also transferred back to the driver in the function getGUIParameter. And this means the function gets a dictionary from SweepMe. In this dictionary, SweepMe puts all the keys in that we have used previously and adds the selection of the user as the value. Now you are free to get the value and save it as a variable, and then you can process it in your later functions, in your semantic functions like initialize and configure. For example, here is one variable saves self.portString, and we could later on use self.portString in connect to send a command to an instrument. We have changed the system a bit with set and getGUIParameter. Let me go to the documentation of the driver programming. You can find it here in the wiki. Driver programming, I already opened it. And there we basically wrote everything in that I'm telling you right now. And there's also something with dynamic GUI parameters. We have also added a new set of functions that are called update GUI parameters and apply GUI parameters. They are now step by step replacing these get set and get GUI parameter functions. And the advantage of these dynamic GUI parameter functions is that you can now change the dictionary that you return based on input parameters. This means, let me show you this as a driver. Let's go to this artifact engineering driver. And I think there was action. I think it was this driver. I'm not sure anymore. No, it was a different driver. Yeah, no, it was this driver. You can see here, when we change the unit to a power unit instead of a current, it wants to know the sensitivity. And whether you have to enter the sensitivity or not depends only whether you have a unit in a power unit or a current unit. So if you go to current, it is not shown to the user. So you know you don't have to use it. And if you go to watts, a new field pops up. And this is now possible with our with these dynamic GUI parameter functions, update GUI parameters and apply GUI parameters. You get at every step, you get the current selection, and depending on the current selection, you can change again what is shown to the user. It means SweepMe will iterate through these functions until there is no further change. And this is how you can make the user interface more and more intuitive to the users and only provide these options that are really needed. This parameter box is available for some modules. For example, for these very generic modules like Logger. Logger is a module where you implement a driver that is that does not fit to the other instrument modules. That is a generic driver for getting data from an instrument, like a logger, let's say, like a temperature logger, a sensor, and so on. There are other modules that also have this parameter box, but there are also modules like SMU. And these SMU modules, they have fixed properties and a fixed user interface. The idea is that if you change between two different instruments, for example, an instrument from Tektronix, from Keithley, or from Keysight, you can change the driver, but the layout stays the same and it still looks familiar. So it's more easy to exchange equipment at your setup. If one instrument does not work at a day or has been borrowed by a colleague, you can simply change the driver, but the user interface stays the same. But this only works for drivers that, or for instruments that are, let's say, belonging to a certain type of instruments like SMUs, where you have certain standards that they always use voltage and current as the return value and so on. For all the other drivers, it is better to go into these more flexible logger modules or switch modules. Here it is the same procedure. These keys are defined in the wiki or are described in the wiki. We can go here to modules and SMU. And you can see that we have here different options. And you can then see what is the driver parameter key, like range voltage, range, speed, and so on. And this means if you go into a driver for a SMU module, we already had one open here for the SMU from Aspect Systems. When we go to these functions, set and get GUI parameter, you can see that we set these GUI parameters and we use exactly the keys that are predefined by this module. And then we get these keys exactly back and can retrieve the data here, like the protection by using the compliance value from the user interface and so on. Okay. Let's go to the port management. Port management means that you have to interface with these instruments and you have to send commands. And there are some kind of standard options to make this easier. A lot of instruments are running with either a COM port, a GPIB, USB TMC, or TCP/IP. And instead of every time writing again into the driver how to make a connection to a GPIB device, we have tried to make this as simple as possible by adding a port manager. If a driver activates the port manager using this line, self.portManager true, SweepMe will open a port for you automatically and hand it over to the driver in the connect phase. So you can start using and writing immediately commands to your instrument. And this is what we, of course, recommend to do it like this. If you have these standard ports, so you use the port manager, then you define the port types. If I now go to my driver, or let me first save this change. I go to my driver, my model, I use find ports, and we can see it found no 2 ports. I think I have a problem here at my computer because I have just a new computer and Visa is not installed yet, so we didn't find any Visa related drivers here at this computer. But the idea is the SweepMe automatically finds all COM ports, all GPIB ports, all USB ports, and presents it in the port type files. There's no further function that you have to write to find ports of these kinds of these types. Additionally, there is the self-port properties dictionary. If you activate it, you can define a couple of options, like the timeout, the baud rate, and EOLs, also end-of-line characters, also terminator characters, that are applied to these ports that are opened. And again, in the wiki, we can go here to programming guide, port manager. Here the port manager is explained again with these port types, with port manager true, port properties, and you will find a list of all these types of these properties that you can add to the port properties, and for which interface they apply and which type they should have and what is the default value and what their meaning is, and you can add them. And the idea is at the end you get a port object that is completely configured. It has all the properties that you need. It is from the correct type. It is open, and in connect in Connect, this self.port object is now ready to go. It is not here added in the example, but I can just add these lines. Just starting from Connect, you have this function self.port write available. And you can send a command like IDN question. I guess a lot of people notice this is this typical Skippy command for getting the identification of an instrument. And if I want to read it, I can use ID equals self.port read. That's all. You don't have to add any terminator or end of line character anymore. You don't have to care about the encoding. You really just are chatting with your instrument. That's the idea, to make it really easy. And the nice thing of the port manager is that some instruments have multiple port types. They have COM port and GPIB port at the same time. And instead of writing into your code always something like if else, like if COM port, then use this, if GPIB, then use this, the port manager automatically wraps this into a single port object that can handle GPIB, COM port, USB TMC, TCP/IP, and so on, and sends the command correctly. And this means this driver then automatically works with all these port types, and you don't have to struggle with how to send a command via a socket or TCP/IP or GPIB. And that's the main thing. It means you write then commands, you read it back, and you can store it, you can handle it, and you can use basically pure Python here in these drivers to handle your data and get your measurement. Okay. And we have also some wrapped communication commands that I want to speak as a next thing. Let me check whether I find a good example driver for this. Yeah, this is also a good driver. I told you already about the semantic phase functions. It means we have something like disconnect, initialize, configure, and so on. But what you can now also often see in our drivers, that after call, after the last semantic function, you can find functions that are wrapping the communication commands of the instrument. For example, there's one command at this transimpedance amplifier to set the auto gain. And you can now have a function where you can hand over the properties that are needed for this function, and where this single function is handled correctly. And then you can use these functions, these communication wrapping commands. You can then use them again in your semantic functions. This makes your code very clean, because now you can really read it like a book. We know, oh, configure, what do we do there? We set auto zero reset. We make the auto gain, we set the polarity. So you need less and less, let's say, also comments, because the functions are often having a name that make them somehow self-explaining. The code gets very easy to read, and it's very easy to understand what is actually basically done in the driver. And you outsource the let's say, all this additional things like having the correct auto gain value set and so on into a single function. And this has also an advantage, that you can use this driver in own Python projects and can directly access these single communication commands. So we want to give our drivers a double use by having, on the one side, we have a connection to SweepMe using the semantic functions, but we can also populate drivers with wrapped communication commands to use them in individual projects to make the driver better readable and understandable. So now we come to another topic, which is also about adding libraries. SweepMe comes with a lot of Python libraries that you typically need for daily use. This could be something like SciPy, NumPy, Pandas is included, and a lot of things that you typically use with Python. But Python is really a large ecosystem, and it's not possible to ship our SweepMe with everything from Python. Yeah, this would make it completely very large executable. And therefore, some drivers sometimes need to ship their own libraries when they need special libraries. And here, for example, this driver, this transimpedance logger driver, needs this FTD2XX library to come with to load it. So let's have a look again into this driver to see how this is done. I have to switch to SweepMe, to the version manager. I go to this driver, I will open the version from the server in a new folder. And we can see you can add a libraries folder to your driver. And in this libraries folder, there can be libraries like for 64-bit and 32-bit, for example. And therein is, for example, jetzt now your library. And the easiest way to add a library is to use a requirements file. You add it to your libraries. And if I open this requirements file, for people that are familiar with Python, they know that the requirements txt can be used to define a Python environment. And what you do is you take the name of your library that you need and tell which version you want to have shipped with. And we offer, or we have a tool that is called Library Builder. And you can use this file with the Library Builder, and it will automatically create these libs folders for you and put them in here. And it will search for all subdependencies in these libraries, in these packages that are not yet shipped with SweepMe. So this is one option. Because of time, and we have just 5 minutes to go, I cannot really go into the library builder details, but you can find this also in the wiki. Another way of adding a library is you can basically do it manually. You can simply add your library to the libraries folder. When SweepMe detects a library folder, it will add this folder to the Python path. So Python will have a look into these folders whether there is a library, and then you can really just use import your library. Yeah. So again, we try to make driver writing as much as possible convenient to add libraries and use them. And sometimes you also have to add libraries in terms of dynamic link libraries. It means CDLLs or .NET DLLs. Again, you can add these drivers to your libraries folder and to your driver. Then you typically have to use libraries like, here I have to go into the other driver that I can modify. Here you have to use libraries like import C-types for loading DLLs, or you can use import DLR for loading .NET DLLs. These libraries are shipped with SweepMe, and you can look into all the other drivers that are open source on GitHub to see how other drivers are written with these libraries just by searching for imports of these libraries. So now let's come to how to contribute a version. First of all, why does it make sense to contribute a version? You can use in SweepMe a lot of free drivers that other people contributed and that came through the project. So I think it also makes sense to put back drivers to the ecosystem. This helps that new people come, and again, further drivers are written. It means the more content on the platform, the more users, the more new content will be created, and the chance gets higher that you have already a driver available that you can directly start and that you don't have to program again. If you write your driver and you keep it on your computer and you don't share it, there's also the possibility that at some point somebody else will write it and share it, and then there is a driver with exactly the same name or a similar name. This will also create confusion. Of course, if you create drivers that are just individual for your setup, where you use a microcontroller for your individual sensor setup, you cannot share it. This makes completely sense to us. But if you write a driver for an instrument that is publicly available, that everybody can buy, I think it makes sense to think about a contribution. And if you contribute a driver, we make a free check of the driver and give you a feedback. I think this is also a good thing then to see what we think about a driver. And we are really happy about every driver contribution, even if it is just a really first step, because every driver that already makes a communication with an instrument can be of great help for other people to get started. Another argument to contribute a driver is that once you contribute a driver, somebody else might jump on and add a new feature. And if they also put it back, you can use it again. And I think from this perspective, it makes sense. The way how to share drivers is typically that when we work with companies and of course also institutes, we make for a transfer agreement to make sure that everything is from the legal point okay. And then there are two ways. You can either send us a driver via email and we will check it and upload it, or you can use our repository. And this means you can clone our repository sorry, yeah, this exactly. The instrument drivers, you can fork it. Sorry, yeah, you can fork it. Then you can add your changes, and then you can make a pull request. This is, of course, a little bit more for experienced programmers, but we can also help you with setting this up. This makes it very convenient for us because we can then also publicly discuss the changes and include it into our system. And it's also clear that the driver came from somebody else and not from us. Okay. There are two further points. I know it's already 11 o'clock. Please stay. I will now go through these points, and then we also will have time for questions. The next thing that I want to show you is a library that is called pysweepme. pysweepme is an open source library, and it is used already in our own Python drivers to create, for example, this empty device class for the devices. So the idea was we outsource a part of SweepMe into open source code, into pysweepme, where all the port handling is in, all the driver creation is in. And this means with pysweepme, you are able to run a Python driver in your own Python project without writing convenience functions on your own. They're already included in pysweepme. And pysweepme is a library that you can simply install with pip, like a normal Python library. And you find a simple example. There's one line of code that you need to load a driver and start running first commands from a driver. You have to add the name of the driver, the location of the folder where the driver is in, and the port string to open the driver. That's it. And then you have a ready-to-go object. You can directly call commands like connect or call or all these semantic functions and so on. I can show you once again a driver here from this transimpedance amplifier. It comes with an examples file. If I go into the examples file and move this file here into my notepad, you can see that we exactly use this getDriver function to load an instance of the driver. Beforehand, we defined the name and path and the port string. And now we can start using functions like find ports, connect, initialize, and so on. We can also use that parameter to override these user interface standard parameters, and then run functions like configure or TCA get measurement. Okay. And the thing that I would like to put your attention on is that if you go to our webpage, and you go to contact and support, you will find now AI assistances that we have trained. We have one for creating sequences. We have one for our support AI, which has the knowledge from our wiki, for example. And we have a driver writer AI. And if you go to the driver writer AI, it's simply hosted by OpenAI, like using ChatGPT. And here you can really directly speak with AI. And you can, for example, say, please write me a driver. Please write me a driver for a Keithley 2400. Of course, this is a very simple example because there are a lot of code snippets in the internet available. But here you see it kicks out now a driver. And the nice thing is you can see it loads the empty device class from pysweepme. It hands it over to the device. It makes the init. It makes the super init. It defines voltage and currents correctly. It uses the port manager with GPIB COM. TCP IP, I think, is wrong. It has not this communication channel, but it still probably will work. It creates set and get GUI parameter. It has now connect, initialize. And even though this driver might not completely work from the beginning, it is already a really good starting point to go through these functions and wrap it. There are also wrap functions like set voltage, set current. So actually what I see here is already a nice start. You can also upload PDFs, programming manuals, and get started with this. So this is what we continuously develop and where we put also these open source drivers into it so that it gets better and better. As a last point that I forgot, regarding the port management. So sorry, I have to go back to a point that I was already speaking about. When I said that you have this port management, sometimes you cannot use our port manager because you need to find your ports on your own from your own library. And in this case, there is a function find ports. And if you use find ports, you can completely take care about the port management and return a list of port strings that you can use later on to open your port and connect. So this is one thing that I forgot to say and to mention. With this, I'm basically through the content that I wanted to share today. And now, please feel free to write a question to the chat or simply raise the hand again or just start speaking if there's any question. Yeah, I guess it maybe was a lot of information. But as I said, we want to provide the video later on, so one can maybe scroll to one or other part of the meeting and check it again. So then there's one question. Is it also possible to write drivers for user interaction? The drivers itself have a more limited user interaction during the measurement. It means you can create your parameters here in this field to have a user interaction, but during the measurement, there are only a few functions in pysweepme available that allow you to ask a value to the user or send a message to the user, but it's not a big thing. If you really want to go into stronger user interaction, we have these add-on modules like custom function where you can create own widgets for the dashboard and where you have the chance to have more advanced features to interact with the user. And we have also an add-on module that is called, for example, user IO. And user IO allows you to throw message boxes to the user. You can use input boxes or output boxes as a warning, and they can come with a text. So it is also possible to create this as a part of your sequencer flow. Our idea is also to, to really modularize these things. If too many user interaction is already in the driver will not be a pure Python driver anymore. It has then to come with additional libraries for the user, for the graphical user interface, and this makes them not pure Python. So we try to modularize this and split this. And then the driver is returning some data, and you can use other modules to create, for example, a user interaction. Okay. Looks like there are not so many questions. If you have some questions afterwards, also feel free to use our forum. Really can make, I want to make some advertisement for the forum. The forum, I think, has really got a nice place to discuss things. We have now every week, we have new topics and issues. And this is a great way to also exchange knowledge for everybody. So also feel free to use this. Good. I'd like to thank everybody who joined. There's maybe one question that is coming up. Okay, yeah, already some goodbye message. Thanks a lot. Yeah, thanks a lot for joining. Hope to see you in the one or other meeting soon, and have a nice day, and also enjoy the Christmas time and a good start into the next year. Yeah. Thanks and bye.